Okay, so in the example of Tower of Hanoi, I started by doing some calculations before the video started, and I found that the first term is 1, the second term is 3, and so on and so forth. So I'm supposed to look at all these things and use iterations, so I'm supposed to look at all of the numbers and try to guess a formula in general. And so the formula I'm guessing is that this is less than, 2, this is slightly less than 4, this is like less than 8, this is less than 16, this is less than 32. So the numbers I'm seeing are 2, 4, 8, 16, and 32. So that tells me that there's a power of 2 going on somehow, but it's not exactly that. They're taking away 1 from this. So in general, for like example, for the mkth term or the mnth term, to get it, I'm just gonna square or cube or whatever, and then take away 1 at the end. So let's see, does it work when n is 1, for example? I get 2 to the power of 1 minus 1, which is gonna be 1 at the end. So it works. When n is 2, that would give me 2 squared minus 1, which is 4 minus 1, which is 3. So it seems like it's working. So my guess seems to be working for n that is greater than or equal to 1, basically. And now I have to actually try to prove this, and I'm gonna do that proof by induction. So here we go. So on one hand we have m1 is equal to 1, and on the other hand we can use the 2n minus 1 formula to generate the 1, and that seems to be working. So that's the base case, and now we're about to start with the inductive hypothesis. So okay, so now that we've made our assumptions and we have our goal, let's go back and kind of review a little bit. What was the mk? It was this. So let's go ahead and rewrite it. So we know that already. We know that mk is equal to 2mk minus 1 plus 1 on the outside. So then we can basically use that recurrence relation to guess the mk plus 1 value, which is going to be 2 times mk plus 1. So why am I doing this? I'm doing this because my goal involves writing k plus 1. So I'm going to get k plus 1 by replacing all the k's in the formula with k plus 1. And so by doing that, I get the formula mk plus 1 is equal to 2mk plus 1. Alright, so why do I care? I care because now the mk itself is going to be replaced with the 2k minus 1. So if I did that, I would get 2 times 2k minus 1 plus 1 on the outside, which means that this is now 2 times 2 to the power of k minus 2 plus 1 by using the distributive property. And this is literally the 2k plus 1, because when the bases are the same, we add the powers. And then negative 1 plus 1 is gonna, negative 2 plus 1 is gonna be negative 1 at the end. And let's see, is that what my goal was? Let's verify this is matching exactly with that. So perfect, that means we're basically finished. So QED.